All right, so let's talk about the oxidation of alcohols to carbonyl compounds. Before I get in depth, this is the portion of what I need you to go through and actually take the time to memorize and understand there are two types of oxidation reagents. You have mild or weak versus strong. Now, it plays an effect to when we add them to different types of alcohols, how they'll react. So PCC is one of them, which is pyrimidine chlorochromate. Don't take my word on it. You probably want to go look it up. And then that's the structure of it. So sometimes instructors get a little sneaky and they actually want you to know what these things are. Like, oh my God, how rude of them. Put it on a note card and memorize it. Get it over with. Okay, great. Now this one, the Des-Martin periodane, please, everything that I write, memorize it as a unit. That is this structure, which looks crazy. All of these things that are connected to that I are acetic acids, so OAC. Making sure that you memorize these properly, so that way, in case they don't write it out like this, they may draw the structure and you need to know the difference, and it falls underneath the category of mild or weak. Then the strong ones, all of these are strong, and my little hint to recognizing, just in case you can't memorize all of them, they all have a lot of oxygen components to them. So strong associated with more oxygens, which would really help later on when we do these reactions. And I put H plus or acetone. H plus, you have your list as any type of acid, H3O plus, H3PO4, H2SO4, even acetic acid. So these are the things you need to memorize for this section. Now in this section, let's talk about what oxidation is. Oxidation is going from a single bond to a double bond, and it's the removal of hydrogens from the original structures. So I'm gonna kind of work upwards from bottom up, only because I think you'll get that concept a lot easier. So remember, we have our mild and weak that we memorize. So you'll see me use the words M and S to denote that chart that I just told you that you need to look at. So where the alcohol is, let's discuss what we see. It's tertiary. So do we have a hydrogen at this carbon? The answer is no, because the four groups are all occupied by other groups. So because there's no hydrogen there, whether I use a mild or a strong reaction or a strong oxidizing reagent to try to oxidize this picture, nothing will happen. So you are allowed to write no reaction, or you can just write the structure over again, which lets them know that you understand nothing changed. Now let's try another one. So I worked this out with the secondary one because it's just really helpful to see when I do the primary ones. Now, the O in brackets is, I probably should have explained that first. The O in the bracket stand for oxidation. So when I look at the secondary one, I just want to put this there so you can associate with the chart. So I look at the secondary one, it's connected to a methyl ethyl, and there's a hydrogen here. So yay, it has a hydrogen, which means it can be oxidized. So let's for a second pretend. Now, is this the right way? The chemistry gods would probably shoot me, but that's fine, because my goal when I tutor y'all is for you to understand. I want you to get the technicalities of it, so I can always create a video on the in-depth reaction and mechanism, but y'all don't even want that. So let's continue. So the secondary one, you have the oxidation symbol. Let's pretend we put the oxidation symbol right in between the hydrogen of the alcohol and the hydrogen of the carbon that the alcohol is connected to. Doesn't that look like H2O? So let's say I removed That oxidation reagent is going to help me remove hydrogens. Oh my God, it's the definition happening right here. Now, when I remove the hydrogens, the remaining electrons, so like this blue line right here, would go to make a double bond between the oxygen. So now this would look like here's the oxygen and the carbonyl would go there. So every time I have a secondary alcohol, now what can I oxidize it with? Anything that's mild or strong. Go back to that chart. If I oxidize a secondary alcohol, I will always get a carbonyl compound, and the name of this carbonyl compound, or the functional group name, is a ketone. And this is always, it's a permanent style of reaction. This is always going to happen. Now you see, I wrote the primary one twice because let's see why. A primary alcohol, oh my God, that carbon has 2 hydrogens. So that must mean I can oxidize it in 2 different ways. Oh snap. So I'm gonna do the first one. So now I'm gonna go from top to bottom. You're like, why is she all over the place? I could do that. And I have my reasonings. So if I don't have to share them either. Haha. So when I have the primary one and I use mild, what are my mild ones? Flip back to the sheet or the video. That is PCC or desmartin pyridine over the dichloromethane, the CH2Cl2. Always make sure you have solvents as a part of your problems, guys. So now if I do the same kind of concept and I remove, just like I did for the secondary, and I remove those hydrogens and created a bond right there, my problem would now look like this. Now that blue hydrogen, one of the blue hydrogens is still there because I didn't touch it, but I created a double bond between the oxygen and one of those hydrogens. So whenever I have a primary alcohol and I use a mild reagent, I will always get the functional group of an aldehyde. Now this may make sense from starting from this portion right here. What happens if I try to oxidize the aldehyde? Can I? Yes, because there's still a hydrogen right there. Does it matter what I use to oxidize that aldehyde? No, it doesn't. I could go mild or strong. So if I go from an alcohol and I use mild, I must make an aldehyde. If they give me a structure that's already an aldehyde and they want me to oxidize it again, the issue is normally I'm removing hydrogens, right? And I tend to remove 2 at a time because in our example, it makes it look like water. In this case, I can't do that. So the oxidizing agent that's being used, it tends to be strong because remember, the strong ones have extra oxygens on them. So it ends up donating a oxygen group, keeping this hydrogen there, but making that oxygen or that hydrogen change into an OH group instead. So whenever I have a primary alcohol, I can do intermediate changes where I can make it an aldehyde and then a carboxylic acid. CA is my abbreviation. Now this is 2-step, but if I wanted to start from a primary and immediately use a strong reagent, I'm immediately gonna get a carboxylic acid. The only difference is my picture looks different. So here, for the carboxylic acid, you see how it looks exactly the same, but right where the 2 hydrogens are, that would come together to make your carbonyl, and that's your carboxylic acid. I would really memorize this in a chart format so that way you'll see when I start talking about reduction how it correlates. So understand, summarize, and really memorize your 2 types of oxidation reagents for these problems.